So you need to have a little practice just to recognize how much savings we're going to make. But never again will you have to face elaborate geometric arguments like this. So let me just add a little bit of notation for definite integrals, all right? And this goes under the name of Riemann sums. Named after a mathematician from the 1800s. So this is the general procedure for definite integrals. We divide it up into pieces. And how do we do that? Well, so here's our A and here's our B. And what we're going to do is break it up into little pieces, and we're going to give a name to the increment, and we're going to call that delta x. So we divide up into these. So how many pieces are there? If there are n pieces, then the general formula is always that delta x is 1 over n times the total length. So it has to be b minus a over n. We will always use these equal increments, although you don't absolutely have to do it. We will for these Riemann sums. And now there's only one bit of flexibility that we will allow ourselves, which is this. We're going to pick any height of f between in the interval, in each interval. So what that means is, let me just show it to you on the picture here, is I just pick any value in between. I'll call it Ci, which is in there, and then I go up here and I have the level, which is f of Ci, and that's the rectangle that I choose. In the case that we did, we always chose the right hand, the largest, which turned out to be the largest one, but I could have chosen some level in between, or even the left hand end, which would have meant that the staircase would have been quite a bit lower. All right, so any of these staircases will work perfectly well. So that means we're picking f of Ci, and that's a height. And now we're just going to add them all up. And this is the sum of the areas of the rectangles, because this is the height and this is the base. This notation is supposed to be now very suggestive of the notation that Leibniz used, which is that in the limit, this becomes an integral from a to b of f of x dx. And notice that the delta x gets replaced by a dx. So this is what happens in the limit as the rectangles get thin. So that's as delta x goes to 0. And these gadgets are called Riemann sums. This is called a Riemann sum. And we already worked out an example. This very complicated guy was an example of a Riemann sum. All right, so that's a notation, and we'll give you a chance to get used to it a little more when we do some numerical work at the end.